Okay, Bismillahirrahmanirrahim. Uh, Let us continue uh, the lecture. So we have started the production of induction motor, and we have started the discussion of fault or abnormal condition in induction motor. So in this scenario, we have discussed the thermal overload protection. For this 49 number relay is used, and then we have discussed the protection against unbalanced current. So 46 relay is used, and then protection against phase reversal. So 47 relay is used, and protection against phase fault. 87 relay is used. So now we have to discuss the protection against stalling or rotor, lock rotor. Okay, so the stalling protection is required in a motor at the time of starting or running. Any motor can dissipate more heat during the running condition than it is when it is in standstill condition. So if motor fails to start after the energizing, then the heat produced into the rotor and starter winding is 10 to 15 times the heat produced during the rated condition. Okay, so for this purpose, the relay used is number 51. Okay, the relay is relay 51. Okay, so so the motor with standstill, this type of extreme heating condition only for a limited time period or limited duration. So this time period or this time limit depend on the applied voltage, and that is the I square T, where I square is the current that flows through the winding of the motor, and is the T is the time. Okay, so a relay with I square T characteristics can be set for any permissible overload. Okay, so the protection in case of stalling, that is applied by two ways. The first stalling protection is given at the time of starting of the induction motor. So the function is activated only during the starting of the motor, and that is during the course of starting. Okay, so T start, that is to be specified. It uses a speed signal from the motor and the time delay, that is T stall. Okay, T stall. One is T start and the other is T stall. T stall is the delay time. Okay, and the starting time is T start. It uses, okay, so T stall is this stalling time that is specified by the manufacturer of the induction motor. Uh, on a detection of start of a start, this function is activated, and the time delay provided for the safe stalling T stall that begins. At the end of this time delay, the motor should gain the required speed. If motor does not gain the acquired speed or required speed, then it is an induction of locked rotor or stalling condition, and relay generates a tripping command. Okay, so some safe stalling time that is to be provided, and during that time period, if motor gains a sufficient speed, then it is not a locked rotor condition. But if motor is not able to gain the sufficient or some specified speed before the stalling time expires, then this is an induction of the log rotor condition. Okay, so the second type of that is used as the stalling at the time of running. So this type of function is activated immediately after the starting period, that is T. So that is T start. So two parameters are required to be set in the relay. The one is the rotor stall current threshold, that is I stall, which is normally one third or one half of the full load current of the motor. And the second, that is the stalling rotor time, that is T stall. The relay detects the overcurrent caused by the stalling and generates a tripping command if the phase current exceeds I stall value. Okay. The relay detects the overcurrent caused by stalling and generates a stripping command if the phase current exceeds I stall value. So the two settings are provided in the stalling relay. The first is the current setting, which is usually 150 to 600 of the relay rated current. Basically, it is related to I stall. Okay, and the the time setting range, which is usually provided, is 6 to 60 seconds instead of 5 or 10 seconds. Okay, so the normal practice for current setting, that is I stall setting, that is one third or to one fourth of the starting current of the induction motor. So the time setting, on the other hand, that is done on the basis of the accelerating time of the motor and safe stalling time of the motor. So the time setting should be such that should be higher than the acceleration time of the motor, and it should be lower than the safe stalling time of the induction motor. Okay, the next point or the phenomena that is known as loss of load protection of induction motor. So the sudden reduction of the load from the motor, that is known as loss of load, may be loss of the load that is because of the breakage of conveyor belt, or maybe because of the prime failure of the pump or shearing of the drive pin. So it is mandatory to trip the motor in this situation. Okay, so when the load that is suddenly taken away from the motor, so the usual practice is to use definite minimum time delay relay, which recognizes the difference between the no load before the application of the load and no load uh, and no load after the application of the load. So in this relay, three parameters are required to be set. That is, first, under current threshold, below which current is this current, and the second is the time associated with this threshold, in how much time this under current uh, this undercurrent that is available or achieved. And the third is the inhibit start time delay. The next phenomena, the next phenomena that is known as under voltage protection of induction motor, and the relay or protective device number that is given as 27. Okay, so when there is a reduction in the voltage below the rated voltage in the running condition, of the induction motor, then the current drawn by the motor that increases beyond the rated current of the motor or full load current. Hence, the insulation of the motor winding that is damaged because of the extensive heating. Thus, the under voltage relay gives protection against this type of phenomena. Okay, and the typical setting range of this under voltage relay, that is 70 to 100% of the rated voltage. So it is normally specified that if the voltage in case of induction motor reduces below say 80% or some value, say 75%, then the under voltage relay comes in picture and it activates, and it is going to give the signal or tripping command to the circuit breaker. Okay, so if I just draw the detailed protection scheme of the induction motor, then you can see here in this figure. So this is the bus bar. Okay, so in this bus bar, and along with this bus bar, we have three phases: phase A, phase B, and phase C. Three phases that are there along with the circuit breaker. Okay, this is the circuit breaker along with each phase A, B, and C. And you have the induction motor. This is the induction motor. I am here. This is your induction motor that is grounded through some resistor or reactor. Okay, these are three winding of the induction motor. Okay, and you can see that along with this induction motor three CTs are there in each phase. Okay, these are the three CTs in each phase, and this signals are given here: IA. Okay, this is IA, IB, and IC. Okay, this the signal of these CTs will be given here to the digital relay. Okay, that is known as core balance current transformer. That is for just to acquire the residual current in case of induction motor. So you have the four current signals that are available. Okay, this is the four current signals, three phase and one earth, IE. This is the earth current signal. Okay, The one more thing that is that the signal from this winding that is also given to the digital relay, so that if any temperature measurement is required, then this is also to be carried out by the digital relay. So the measurement of the temperature, maybe some method like RTD resistance, or the temperature detector or thermistor, that is to be provided in the digital relay. So you can see that along with the CTs, the PTs, are also provided. Okay, three-phase PTs, because if I wish to achieve the under voltage phenomena or like that, then I have to connect the under voltage relay on the secondary side of the PT. So PT is also required. Okay. So that was all about the induction motor protection. So let's review the lecture. So we have started with the application of the induction motor. Okay, so the production of the induction motor is needed because it is directly concerned with the revenue. So if a loss of the motor occurs, then it means we will have an ultimate loss of the revenue. So all type of electrical and mechanical faults should be considered. So in electrical fault, we have discussed different phenomena, starting from overloading, the overcurrent, and that is the short circuit current, the negative phase sequence, the phase reversal, the stalling, the phase unbalance, and so on under voltage. So after that, we have also discussed the ranges, the setting ranges, and the curves for the thermal overload protection, and also the setting ranges for the IDMT or DMT release. Okay, for each type of the protection cars, we have specified number for each relay. That is for the thermal overload protection, we have the 49 number relay. For protection against unbalance, we have 46, and for protection against phase reversal, we have 47, and protection against phase fault 87, and protection against stalling or locked rotor, we have 51. Okay, so the under voltage protection of induction motor, we have 27. Okay, so that was all about the protection of induction motor. So in the next lecture, we will discuss the protection against the transients, and we have also a lecture for the circuit breakers and the fuses and production of bus bar, and at the last we will discuss the testing and commissioning of the relay. Okay, so that was all about for the today's lecture. Thank you.